Anyways,
That worked out then.
Mhm.
All right. So my name is Jason Gunthorpe here, and I'm going to talk a little bit about rdma core. I think I talk about this every year. So I try to find things that have been done in the ecosystem that seem relevant to the UCX community, for particular relevance to HPC. There's an awful lot of stuff that goes on that's Ethernet focused that has to do with Kubernetes and DPDK and things that I tend to exclude. So the good news is things are still trucking along in a pretty good way. This is about the same as last year in terms of volume of activity. There's quite a lot of people that contribute to this. It's a big, healthy community in a lot of regards, and we churn out a lot of code every year. I think this is probably the most significant one for a lot of our HPC people, is that the kernel now understands how to do relaxed ordering by default. Relaxed ordering is a PCI function that allows the processor to optimize the memory accesses relative to the cache coherency protocol. And modern CPUs get a significant performance boost when relaxed ordering is used properly. So we want to see relaxed ordering turned on basically everywhere that it can be turned on. Last year, I talked about relaxed ordering support in rdma core itself, which could be used by something like UCX to get those optimizations. And now we see it done for the storage ULPs in the kernel, things like IP over IP as well. And for something like UCX, we've added this new verb called query QB data in order, which tries to query some of the device and platform specific information to see if the non-relaxed ordering transfer modes have a chance of being in order. So there are some platforms like PowerPC that never supported the kind of the in order optimization. And there's some operating modes on some NICs, like we're just hearing about EFA, for instance, that are never in order anyway. So something like UCX, if this returns false, it really does mean that last data pulling is not going to work. And you shouldn't try and do anything like that. And you must rely on completions to signify data delivery for everything else. And I think the whole world is moving in this direction. The performance gains from relaxed ordering at the PCI layer are significant enough. And the improvements in the networking layer for not strongly putting packets in order is also quite significant. So we might be coming to the end of the era of the last data pulling optimization. Yossi has already talked about DMA buff, but here's my little bit. So we have DMA buff support in the kernel and in rdma core. DMA buff is a kernel API that lets you take a chunk of memory basically and feed it out as a file descriptor. The file descriptor has some very special semantics to it that allows a device like the rdma NIC to interact with the GPU in a way that the GPU finds acceptable. So it's not quite the same as something like a memfd or a shmemfd. It's got some protocol hidden inside the kernel, but from the perspective of UCX, it doesn't really matter. You get the DMA buff FD and you create it into an M key and an NMR, and then you close it and you're done with it. The two drivers that implement it are Efa and Mlx5. Efa has a kind of limited version of DMA buff that requires the GPU driver to leave the memory fixed forever. And the only upstream device that's compatible is the AI accelerator from Habana Labs. Mlx5, on the other hand, supports all the GPU drivers, including Habana Labs and the AMD driver and everything else. I think we might see, it's not clear how this is going to be evolved to me personally. The Mlx5 version of this uses our on-demand paging technology to create the interaction that the GPU driver wants. The GPU driver really wants to be able to move the memory around and swap it here and there. So we can use the ODP technology in a slightly different way to create that synchronization, but it's very it's a very complicated technology that's quite old now and nobody else has implemented. So we may see that DMA buff is got this bifurcation going forward, perhaps across all of the different fabric transports. Not too much really resounded, really called out to me when I looked at the logs for the kernel. By far the biggest piece of work was the new Intel rdma driver. This is a gigantic whole new driver that replaces the old driver, the i40iw, and it supports the new Intel iWarp and Rocky devices. I don't know that they have much of an HPC focus with those devices. I don't know how relevant they are, but UCX does support iWarp. I think I saw earlier again. So this is basically one of the two iWarp drivers we have. It's either iRDMA now or the old Chelsea driver. InfiniBand has learned to have NDR support. The HNS, newest HNS device supports XRC. And we've made a lot of optimizations about contiguous memory. So if you have a system with huge pages or super huge pages or giant pages or whatever, we can take advantage of that. Pretty much all the drivers in various regards can take some level of advantage of it. And Mlx5 can take full advantage. If you have a 1 gig huge page, super huge page, you can map that into a completely optimal hardware structure that will run the device as fast as it can. And some more optimizations for ODP. ODP is still a very neat feature, but it's I don't see it being used very much. I would kind of actually be interested to know what the UCX community feels about ODP. In RDMA core, it learned some import-export for device memory. Device memory is currently only a Mellanox feature. It refers to some small amount of memory that's on the NIC itself. It can be used for DMA for RDMA activities. The IB fork and init thing is interesting. Last year I talked about the kernel side bug fix for fork support. And what we have now is that RDMA core is able to automatically detect the kernel has that support, and then it just disables all of its forkiness. So sometime around, like I think for instance, Red Hat 9 might include the required kernel support. We'll find that fork doesn't have the overhead and the nightmare that it has today. Unfortunately, the kernel support is deep inside the MM subsystem, so it's not going to come through any kind of like vendor add-on package like Mellanox OFED or something like that. A few more providers learned to do the extended verbs, which is nice. They've been sort of sitting out there for a long time. Providers keep adding them a little bit. This is things like the disaggregated post send and receive. And we have, of course, a lot more PyVerbs. PyVerbs, I think, has been a great success here. We have quite a lot of good coverage. It helps keep the API multi-vendor interoperable and other things. Looking only at the Mellanox kind of stack, these features are relevant to UCX. I think UCX will consume them or has already started to consume them as part of enabling forthcoming functionality. So Mimic is the Mellanox name for device memory. It's a special kind of device memory, and the Mimic operations refers to the ability to do atomic kind of things on your device memory. So you can do like an atomic add or other stuff like that. It makes the device memory more useful in a concurrent environment where you have DMAs that are reading and writing it. And you have the CPU that wants to change it as well. And of course, the earlier export and import feature applies to Mimic and the shared DMs and everything. So you can create DM regions that are shared across multiple processes that can be used to accelerate various little details in communication models. This memory window thing is a storage focused feature. For security, we would expect that storage devices do not just expose all of their memory to RDMA. They should be creating short-lived memory windows, is what the spec calls it in user space. The sophisticated features here allow you to a device to do all the things that we can see in the kernel for the storage ULP. So they can do fragmentation, they can do signature splitting, they can do encryption and signing and all that great stuff that storage layers like to have. This is pretty much relevant whenever you want to do storage transports. If you want to do like signatures and stuff, you need to have this. Dct Streams is an upcoming feature in ConnectX 7. Enablement has been landed in all of the lower levels already. This thing with the VFO is quite interesting. It's a new verbs provider that runs the Mlx5 hardware, except that it interacts with the hardware using the VFIO interface in the kernel instead of the rdma stack. So it takes like a complete virtual function over, and it can operate it fully as quite a limited verbs device, but it's still useful for a few things. The rationale for doing this is that there's a number of very exotic use cases that need like absolute control over the VF, and this provider gives it to them in a way that's still kind of ecosystem compatible with the rest of our APIs. So you're still kind of in a verbs world. You've just got like a mini driver in user space working over VFIO. The key management is also another storage thing. When you do encryption on the storage transports, you can have the keys stored inside the device, and the device has a very elaborate way to keep the keys secure and to transport the keys from like an external key vault and transport them into the device in a way that ensures that the key remains confidential and that only a trusted NIC can access the keys. And that's pretty much it. There wasn't too many really interesting things this year to talk about. I think I got most of the highlights. I kind of open the floor to any questions if people had anything to say or anything they'd like to see.
Hey, thanks. Can you hear me? This is Hamel.
Hi, Hamel. Yep.
I have a question in general. You mentioned ODP support, and I want to understand what is there today, and it's not being used. So are we planning to deprecate that support down the road, or if you can go in a little bit more depth on your comment on ODP?
No, I don't think it's on the chopping block. It's just something that it's not widely used. There's the concept of ODP was that you could eliminate the memory registration overheads.
Mm-hmm.
So you don't need a memory registration cache when you're using ODP. And I don't.
Go ahead.
I was going to say I don't really know where like UCX community got to with this feature, if they did performance evaluation work on it or something like that. Decided not to use it.
I think we had Jason one project. I think like we discussed a while ago, where we used UCX for storage with NVD backend and DAX file system.
Yeah.
And pretty much using RDMA over DAX, you must have ODP because of the way DAX decides to move pages.
Yep. DAX interaction is one of the strong reasons why ODP is going to continue to exist. People doing DAX and RDMA absolutely need it. I don't know how that got plumbed into UCX, but like you're completely right that there's certain memory types that are not going to be compatible with a standard MR. When you go down into the automatic memory registration inside UCX, you kind of have to. There's cases where you have to create ODP MRs instead of regular ones, like DAX, GPUs and things. We suspect that there will be use cases with the GPUs too, like where they would want to have ODP for the same reasons DAX has them.
So follow-on question. So at UCX layer, are we providing some kind of knobs to this application to indicate whether they want to use ODP or it's completely transparent to them?
So there is a configuration parameter in the IB layer, whether we want to use a registration cache or ODP. And today the default is use the registration cache. So the main reason to disable ODP by default is because of performance, especially for the first time. We noticed that the impact of misses and especially the flows which involve missing pages and putting it back in and notifying the hardware and everything which is involved in that is more expensive than memory registration. And the second reason that at the time, not sure it was changed, ODP was not compatible with DevX in the sense that when you create a DevX queue, the kernel has no idea that it's a queue pair. So if there is ODP miss, it would not fix the sandbook keys on it.
Yeah, that hasn't changed. That's still the case. But I think ODP is faster now. And I have to sort of qualify that saying that you need a new enough kernel. Like the newest upstream kernels for about the last maybe year and a half have had some significant optimization done to them.
Yeah, but still, unfortunately, we plan to in UCX to fully move to DevX, or at least whatever is DevX will stay that, and gradually move objects and control path to DevX as much as possible to make it more compatible. So yeah, it's kind of a blocker.
Yeah, well, yeah. Getting ODP support with DevX is a task somebody needs to do, I suppose.
We consider something like user space ODP when, I mean, the event would not have to be processed by a kernel, but the user would get the notification maybe for the DevX event channel and would have to fix it somehow.
Yeah, I think the fix it somehow I think this somehow is going to be too messy.
Because it doesn't have access to all the structures of the page.
Yeah, it can't deal with physical PFN, so it can't actually fix it. Yeah, you need to talk to the chip designers and get some sort of agreement about what to do about this.
At least from my early days experience in HPC, there are still we had plenty of applications where applications were Rcache, registration cache with using ECX was not a feasible way to proceed with the application just because of all this delayed registration, the memory pressure that it was creating. So I do see even for HPC space, specifically an application where like very little reusability of pages, ODP can be very beneficial because like Rcache was just hurting them. I have another question. What is Dct stream, if you can elaborate a bit more on this?
I think I'd have to ask Yossi.
Can you go back to the slide? I'm not sure what Pash is asking about.
It just literally Dct streams feature, and
I don't think I'm not sure what this is about.
Okay, we haven't got to it yet then, so it'll probably come later. One of the things that at least NVIDIA is engaged in these days is to make sure that the kernel support for forthcoming device features is done before the devices are available. So some of the things on this list will not be functional until their targeted devices are released.
I think Yossi Mimic support, we had something in UCX which was broken in UCT, but you see it's actually coming properly to UCT with UCX with abstraction around device memory access.
So we do not plan to revive it for the time being. But when we do, we probably need to discuss the proper way to add it.
So it will stay hidden UCD.
Yeah, so it would not provide a pointer.
Okay.
Also, I wanted to note about the fork support. So we actually got some users issues regarding the fork support. Especially, it's related to the fact that in UCX we call IBV regmr after the memory has already been released. And it's related to the way that registration cache is used, because with registration cache, we need to put memory hooks, and we can release it only when the hook is called. But we cannot do it immediately in the context of the hook, because it can maybe can create some kind of deadlock if, for example, it's called from context of malloc, and IBV regmr also calls some heap function. So therefore we do it later. But then it's a problem because the EMA device which does do fork can fail because the memory has already been unmapped by that time. And in some cases, users would map other memory into that region. So it has some kind of partial mapping. And that's why rdma added some code to do unmap page by page, and it causes performance issues in some cases.
Yeah, I saw that. I don't know that we can really do anything much here.
So the bottom line, the question is if, I mean, is there any chance to backport some of this
No.
Logic?
There is one question in the chat. Did you say that kernel support for IBV forking it will be available in Red Hat 9 onwards?
Don't quote me on that. Like I don't speak for Red Hat or what they're going to include, but it's possible. It's the kind of thing where if you really care about it and you're a Red Hat customer, you should bring it up to Red Hat. That's a feature request for Red Hat 9.
Okay, so are there any more questions?